Hello everyone, we move on to the lesson 3 in the chapter 2 limits and continuity. This lesson is to solve limits, computation of limits. I will go through a few problems in detail and then I'll directly tell you a shortcut method which will work all the time. And whatever we have seen in the last two lessons, the same concept is used most of the time. So if you're thorough with that concept, it is more than enough. And then to save time, you can use shortcuts and tricks. Now, the learning objectives in this lesson are find limits for polynomial, rational, and trigonometric function using theorems. Use the squeeze theorem to find limits. So all of these can be solved in the same way. But we will see the keywords indeterminate, rationalizing, squeeze theorem. We'll come across all this. Now, computation of limits. Now, we have seen this limits already before. Now, here we have a lot of theorems and formulas in this chapter. We will look at them one by one. I will just skip through. You can pause the videos and go through the theorems, spending more time on it. But I will mainly focus on the problems, how you can solve it. So over here, you can see this is a constant line at any a. Whenever it's a constant, the limit is the same. That's what it says. Limit of function c, which is a straight line, is c only because you see any point over here, it's just the same. So you can directly find at a, the nearby is the c. Same way over here for any real number a, if you're finding, it'll be the same thing. And there are plenty of theorems how to solve the limits. For example, if you have limit c which is a constant multiplied to a function, you can remove that c outside and just compute the limit of the function and then solve it up. Or if you have two limits, if it's plus or minus, you can add those limit and two functions plus or minus. Limit can be multiplied inside, or it can be multiplied as a whole limits, and it can be divided provided the denominator is not equal to 0. Now similarly, there are more theorems over here about polynomials. It can be for any real number. You can use this formula. We will be using it in the next problems. And same thing over here with the square root functions, and these are trigonometric, some of the rules for the trigonometric functions, and exponential and logarithm as well. This is the range of the sine, cosine, and everything, and then we solve it. And this is for the tan inverse, the range. Okay, now the squeeze theorem as well, what it says is like if your function, if there are two of these are equal, then this will be equal to that particular limit. Now the limit of this and this function is equal to, say, any constant L, then this will be equal to that at that particular same point itself. And now over here we can apply a rule. We have limit of this particular function as x approaches 2. So now you can see there is nothing in the denominator, right? You can easily solve it. If there is no denominator, you can just plug in this value and solve, because it won't be a problem. You won't get a mathematical error in this. That's why. Now you can see over here, this rule in one of the theorem 3.1, second one, it says we can multiply this limit inside. So this limit as x approaches 2 is multiplied over here, here, and over here. So this is how we get it. And then you can individually solve them. Now over here there is one more theorem. If you have a constant, this is a number which is constant. Variable is in terms of alphabets, right? This number is a constant. Remove it outside. So you can compute this. Over here, this is outside, and then you can solve it up, and then you can get the answer. So this is just in detailed method. So you can just keep this in mind, or you can directly solve it. Now over here, all you need to do is substitute the value of 2. So it'll be 3 into 2 squared minus 5 into 2 plus 4, and the answer will be the same thing. So it's just, this will save you a lot of time. But this is by using all the formulas. Now over here, look at the denominator. Will you get a mathematical error? Let's see. 3 cube minus 5, x is 3. Okay, this x is approaching 3 into 3 plus 4 divided by 3 squared minus 2. Now let's see, the answer is 16 by 7, and that is the answer. Why did I do this? If this was 2, I wouldn't have done, I mean, if this was, okay, it's square root 2, I wouldn't have done it because it would be 2 minus 2. But in this case, over here, I knew 3 squared is 9 and it's not going to be a problem. So that's why I directly did it. Or you can apply the limits and you will get the same answer. It's fine. But now let's look over here. Can I directly solve it? Let me put this. 1 squared minus 1 divided by 1 minus 1. What's the answer? I'm getting an error because the denominator is 0. So what did we learn in the last lesson? What you need to do is use a value which is very close to 1, that is 0.99 squared, and wherever there is x, make it the same, 0.99. What is the answer? It is minus 2, almost equal to minus 2. So x is approaching 1. So I use 0.99, which is less, and I have to use 1.01 now. These are the two values. So let me just change this to 1.01. And even in the denominator, I will change it to 1.01. And what's the answer? Negative 2.01. It's almost negative 2 itself. That means the limit exists because both the one-sided limits are approaching the same value, that is negative 2, and hence limit exists. So you can see answer is 2. Or you can use, the identities a squared minus b squared and split it out and cancel it off, and then you can get the same answer. So whichever is easy, Now over here, can you see any denominator? No. So why do you have to bother? You can just put it directly. Shift, and over here this symbol will give you a radical symbol for any power. Now it's 3 into x is 2 squared. Sorry, any root. I told any power, it's a root, right? Minus 2 into 2. 2 as x approaches 2. That is the answer. Now your answer may not be the same thing. See, look over here. This is the answer, right? Okay. Now this is a very good thing. What happened? Okay, I have written it wrong. Sorry. Okay, minus 2. I thought I had missed a bracket or something, or power. Anyways, into 2. Okay, this is the answer. Now, just now, look at the error which I did. Please do not do it. So whenever I do error, I don't, before I used to, re-edit it and, start over or something. But now I just leave it because, some of these errors, you might also do it when you're, trying your exams or practice problems. So it's good to keep such errors in mind. That was a very simple error. But anyways, over here, now the first instant I thought there was a negative value and I did not use brackets, but now that was not the case. I just did an error, but now the answer is not the same, isn't it? It's 515.7, and it goes on. So what do we do now? Let's look at this answer, the power 5, and this is 8. It is the same answer. So now there is one more method to get this directly. So what you can do is, one thing, put it in the calculator, all the answers, and you can compare to the answer which you got. Otherwise, leave this cube root as it is, just solve the inside terms because it's not divided by anything, right? 3x squared, that is 2 minus 2 times 2. Minus 2 times 2, that will give you 8 as well. So outside is root 5 root 8. That's the answer from over here. So this is one another way to solve it. And then now over here, you can't write directly 0. Why? Because it's going to be an error, right? So what do we do? All you can do is, try something very close to 0. So I will have two values close to 0, that is 0.01 negative and positive 0.01. So now all you need to do is substitute that as it is. Now before I continue, I remember in the last video I told there's another way which I forgot to tell at the beginning of the video, so I will tell it now. I told you can use the x, right, instead of changing this and this. So the method is very simple. You have to write this equation as it is in this calculator. So it's square root alpha x. Can you see this? Alpha and x will give you this x unknown variable, plus 2 minus square root 2 divided by alpha x. Now over here, what you need to do, instead of changing it to 0.01, you can just press shift and solve for what x value is over here. This is a already predetermined value which I inputted before. Now you need to just change this to, if you have never used this method, it'll be 0 over here. All you need to do is type a value. I'll type this negative 0.01 and then I'll press equal to. It'll give me the value after calculation. Let me just press equal to. Okay. Now, I'm just wondering, is there any error? So what I realized is, here in some cases that may not work because it's not somehow. Wait, let me take 0.1 and let me try. Okay, it works for many cases, but since there is square root, I believe it's better to avoid this. Okay, we will try it in the next coming videos. It's good that that happened. So that particular method may not work all the time, I believe, but it's much easier when you have a straightforward problem without square root. We will do that. But for now, let us do the method which we're doing from before. And if you're getting confused with the new method, just ignore it. Just do like this. Type minus 0.01 plus 2 minus square root 2 divided by minus 0.01 and press equal to. You're getting 0.3539. Okay. And now all you need to do is change this negative sign, remove this negative sign. And what's the answer? It's the same answer. It's almost the same answer, right? 0.3531. So now what you can do is you can just increase the zeros to see where it's converging. Like 1, 2, 3, 4, 5. I've just added 5 zeros, and even over here 1, 2, 3, 4, 5. And I can see it is almost converging towards 0.35355. So you can see the answer is also somewhat related to that. This is the answer. Now, how do you understand this? So if I solve this particular one, 1 divided by square root 2 plus square root 2, you're going to get the same answer, 0.35355 and so on. So that's one way. Now, if you want to know how exactly this was done, it's very simple. I hope you remember, whenever you have such problems, you multiply by its conjugate and divide by its conjugate, by the conjugate. What do I mean by conjugate is, there is no way to simplify this directly, isn't it? Because it's already crazy looking problem. What are you going to do? So whatever is this term, instead of plus minus, make it plus. That's the conjugate. So this term as it is multiplied by the opposite, like it's mirror image but the opposite sign. Same way, you can't just multiply something, you need to divide as well because you need to balance it. So it's even divided. So this cancels out. It's basically the same equation, right? You're just manipulating it. Now, this term, what happens is, it is similar to a squared plus minus b squared. Sorry. Why? Because a minus b, a plus b. That's in that identity. So what you can do, you can just square this entire term and this entire term. Why? Because it is, see, if you consider a as square root x plus 2 and b as square root 2, then this term a minus b, a plus b, this is what has happened. But instead of a, we have square root x plus 2, the whole square, this square cancels, and over here it is 2 and 2 cancels, so you're remaining with this. That's the thing. What happens is this square root x plus 2 the whole square minus square root 2 the whole square after identity. Now the square root and square cancels off, and you're remaining with this in the numerator. Now this 2 and 2 cancels off, and then you can see simplified so further, and even this x and x cancels, isn't it? So you're just remaining with 1 divided by square root x plus 2 plus 2. Now you can split it further sorry, over here now, the last, so what is done over here, this term, given term, is equal to this term, right? Basically, I forgot what we were doing. We are finding the limits, right? Sorry, I'm just, we have solved it. Why did we do this? Because in the numerator, if you have x and you put the value of 0, it's undefined, right? But now look over here, we have rearranged this entire term to this particular equation. That means these both equations are same. So it's basically, I can apply limit to say over here, limit x of 0 to x squared by x, because it's, or I can simplify this and limit x, right? It's the same thing because it's just simplified. This was not a great example, but what I'm trying to say is these both are the same thing, so you can apply limit to this or this, it doesn't matter. Now we have simplified it and we are applying limit to this one, and now you can easily get an answer because x becomes 0. You're remaining with 1 by root 2 plus root 2. This is how you simplify it. Okay, but if you're getting confused, you can directly do the shortcut method in calculator and you will get the same answer, but just that the form will not be the same. So that is it. And this is more simplified because there are 2 root 2 and root 2. So that's why 1 by 2 root 2. And now here we have trigonometric functions, sine inverse. Same way we can solve them, or you can use theorems. Over here, you're just splitting out by parts and then solving it. Okay, we are just splitting out in 2 different parts and then solving it, like sine limit of this first one is separately done and this one is separately done, and then do it. Or you can directly try and solve it over here. Shift and sine inverse of, what do we write over here? Instead of 0, negative 0.01 plus 1 divided by 2, and just close the bracket. And the answer is, okay, now it's in radians, so it's fine. Now the answer is 0.517. Okay, now same thing, remove the negative sign and you're gonna get, it's almost the same. So in such cases, what you need to do is you need to increase this zeros, 1 2 3 4 5. Now you get a better picture. So the more accurate answer is 0.52359. Okay, this is a more accurate answer. And over here, even if you put negative, it's almost the same thing. Can you see? 0.5259, only maybe one last decimal might change a little bit. Now, but this answer is entirely wrong, isn't it? Now, there are various ways to get, whenever it's trigonometry, best is calculator because it sometimes gets crazier, right? You will get something like this. How do you know what is this correct answer? What is the answer for this? So now, what you can do is this pi by 6, shift pi by 6 is equal to how much? It's the same thing. So pi by 6 equals 0.52359. Now there is one more way. How much, how do we know directly it is pi by 6? So what you do is basically just divide pi by the answer you get. See this answer, whatever you got, right? Now it was there on the answer, so I just saved it. Whenever you divide pi by the answer, you will get what you need to divide by. Okay, so this is one thing. If you get a fraction over here, say it is 1 by 2, then it is 2 pi. So that is one way. It's basically cross multiplication. Okay, if that is not clear, I'll just repeat it. Now we got an answer, right? This was our answer, this was answer 0.52359. Now, whenever you solve in your calculator, you will get answers like this. So whatever the answer you get, if you just divide by pi divided by this answer, that is 0.52359, will give you a round figure. I mean, not the exact answer, but a number which is close to 6, right? So you must know pi by 6 is equal to this particular digit. So this is the thing. Okay. So that is one thing. or you can just solve all the answers, and whichever is equal to what you got is the same answer. So that's the thing. Over here also you can do the same thing, or if you know the range, you can start solving them in various methods, or you can split them up. See, you're just basically splitting them up into two, not directly splitting in this case because it's cot. You need to use cot identity and solve it, and then you can solve, I believe. Whenever it comes to cot, generally we try to get it back to sine and cos. If it is a sine and all, it's easy, okay, we can directly solve it. But if it's cot, we have to bring it to sine and cos and then simplify it. Now here we can try using the calculator. But now, how do we have cot? We don't have cot, right? We know cotangent. What is this cot? It's cotangent. That is equal to 1 by tan. So let me use that. It's in radian mode already. So alpha x, that is 0.01 multiplied by 1 by tan 0.01. Close the brackets, and then the answer is 0.999. Okay. So this is in this but in the first case. Now what about the next case? Minus, right? So let's put minus over here, and let's put minus over here, and you're getting 1 itself. Let's just check. Yes, the answer is 1 in both the cases, and so the limit of this is basically 1. So now here you can see the answer is 1. Now it will not be exactly 1, it will be almost close to 1. And that's the answer. So it will work for any of the trigonometry function, but if it was, say, for example, secant, you must know it is 1 by cos. Then it will absolutely work. Now, if you're thinking how to solve this directly, it's very simple. It's just that cotangent is cos by sine, isn't it? And then you simplify it. X by sine, it can be written as, if you take it to the denominator, it will be sine by x. We have solved it in the last video. It is 1. We have done this limit already. It's like a formula. And now limit of cos corresponding to 0, cos 0 is 1. You can just do it cos of 0, 1. So 1 by 1 is 1. So that is how we come to the conclusion. But if it's cot, because it's not easily available, you can't directly split the limits. You need to rearrange it and write and solve. But in calculator, it's direct. Doesn't matter which problem, you can directly get the answer. Now same thing over here. I'll quickly do it, and then you can try it by yourself as well. So it is close to, okay, there's one more thing. You have to try the lesser value and the greater value all the time, okay? 0.01 negative, 0.01 positive. Let's try this. Now here it is let me take the negative, 0.01 squared. So I will have to use the bracket because there is negative, multiplied by cos of 1 divided by negative 0.01. Okay, then now close the bracket, and the answer over here is, okay, I have done a mistake. I shouldn't have this cos over here. Okay, it's negative 0.01 the whole square. Okay, now it's all right. What's the answer? Now look at this, 10 to the power minus 5, right? So it is basically 0.00008. Okay, by 5 you have to take. So 1, 2, 3, 4, 5. Yeah, so this is the answer. It's almost close to 0. Whenever you see this negative 10 to the power minus some number, that means it's almost going towards 0 because there are so many zeros behind it. Okay, now let's just change this to positive. 0.001 every way. Wherever there was minus, remove it. It's the same thing. It's 0.000862 and so on. As I increase the zeros, it's gonna go more to 0. So the answer is basically 0. You can see the final answer is 0. I mean, the limit over here is the answer. Over here it's just the explanation. Now you can see over here the squeeze theorem is used. You're just basically finding the previous and the next one, and then you're basically solving it. It's pretty straightforward. It's all explained over here. This is the squeeze theorem over here, but you can stick to the calculator method and you'll get the same answer. Remember to use when you're using that squeeze theorem, you need to know the range, and then you're multiplying and trying to get over here, left side, right side. So it's -1 + 1. for cos 1 by x, right? Then you're multiplying what is there, x square on both the sides, trying to get this, and then you're solving the left and the right limit. Over here, left and right limit is what? Equal to 0, so this will be equal to 0. That's basically it. Now, this is about, okay, now this is another problem. Now you can see over here, this is very easy. Why? Though it's a piecewise equation, you have studied about piecewise equation before, so this will work only for values less than 0, this will work only for values greater than or equal to 0. But now we are dealing with limits. So obviously limits means that particular value 0 is not included, whatever, it's either less or greater than, right? So since there is no divided by, there is no rational, it won't give me an answer of undefined. I will just directly substitute this over here. What I'll do, I'll just directly substitute 0 square plus 2 into cos 0, close the bracket, plus 1. What's the answer? It's 3 in this case. Okay, and what's the answer over here? So e exponentially power 0 minus 4. And the answer is negative 3. So what's the answer? Till now, all the problems we solved, we had answer. But this one, you're getting plus 3 minus 3. Limit does not exist. Okay? So over here, the answer is limit does not exist because it's not the same thing. It's not 3 and 3. It's not minus 3 minus 3. It's two different values, positive and negative. So it does not exist. And the last one, okay. In the next chapter, when you do these problems, it's going to just take you 2 minutes. Not 2 minutes, like 20 seconds, you know. But for now, if I'll read it and we will use by a formula. Suppose the position function of an object at time t seconds is given by the function f of t equals t square plus 2 in feet. Find the instantaneous velocity of an object at time t. Now, we need to know the velocity at particular time, instant, at which instant? At 1. Now this is the position. Now there is a relation when you know derivative, you will come to know whenever you differentiate dy by dx, like derive d by dx, over here in this case it's t with respect to time dt, position, I'll write position, you'll get velocity because velocity is the derivative of position. Now, if you remember in physics, you might have gone through differentiation before. So differentiation of this will become 2t plus constant is 0. So the answer is 2t, right? What is the value of t? 1. So substitute 2 into 1, the answer is 2. So this is the velocity, feet per second. Now, this we will learn in the next chapter, but for now, if you're using a problem, then we have this particular thing, limit as h tends to 0, so f of 1 plus h minus f of 1 divided by h. Okay, so what does this mean? This is the given function, right? You must write this function with respect to f of 1 plus h. That means instead of t, you must have 1 plus h. So equals to, now don't write t over here, write 1 plus h, then everything remains the same, square plus 2. Can you see this? So this is the first function. Minus f of 1, what is f of 1? Instead of t, you have to put 1. Instead of t, 1 square plus 2, that is 3. So over here, minus as it is, minus 3. And divided by h. Now you're finding the limit of this. So you can simplify this further. You can use a plus b the whole square identity. A plus b the whole square. It is a square plus 2 times ab plus b square. And then you get this answer. So a is 1, b is h. So 1 square plus 2 times 1h, that is 2h, plus h square. Minus, okay, over here, sorry, I forgot to tell this. In last term when we did the, oh sorry, no, this is right. I thought we have to complete the square. Sorry, no need of completing this way. This 2 is there. 2 minus 3 becomes minus 1. Okay, so that's the thing. And then now you just have to simplify it further. Over here, this 1 and 1 cancels. You're remaining with over here. And now you can remove this h common out, and this cancels. You're remaining with 2 plus h basically. And 2 plus h divided by 1 is the same thing. h is 0, answer is 2. This is such a long method. Otherwise, you can just do the substitution over here and do it in calculator. You'll get the answer. Just make sure you use 0.99 and 1.01, and both the answer will correspond to 2, so that is one thing. But the easiest method would be, which you'll study in the future lessons, that is derivation of, say in case it was x squared plus 2. This 2 comes down and the power reduces by 1, minus 2 minus 1, that will be 1. So it is just 2x, and whenever you are constant, it's 0. So the answer is 2x, and I've just taken it as x, so x equals 1 means 2 into 1, answer is 2. And remember, it is feet, but velocity is with respect to time, feet per second. So that is how we solve this particular problem, and that's the end of this. So limits is not that difficult, it's easy. You can use calculators. There are various other methods as well to solve. Whichever is easy, you can use that particular method. Now I just remembered I told you that method which didn't work with trigonometry, with square root. Let me just try it over here. So all you need to do is write the limit as it is. See, write the question as it is: alpha x squared minus 1 divided by 1 minus alpha x. Now what you need to do is you need to calculate x value. You need to solve that particular value, right? So shift and okay, I did a mistake. Sorry, I had to just press calc. Now I realized what error I did. I was pressing shift. Basically this x is inputted, right? I had to just press calc. So now it asks you, what is the x value? Okay, you will have two x values, right? One is 0.99 and one more is 1.01. Instead of changing the values every now and then, just put 0.99. And now what's the answer? At 0.99, the answer you get is negative 1.99. That's almost, I won't write negative 1.99, it's negative 2. And then now again press calc. Okay, this is done. Press calc. Now change the 0.99 to 1.01. What's the answer? It is negative 2 itself. So this is the shortcut, instead of writing 0.99, removing it and taking it out, you can just do this directly. Now I realized my mistake, so it will work even over here. Let me do it. So what you need to do first is write the equation as it is: square root alpha x plus 2, leave a space, minus root 2 divided by alpha x. Now see this 0, take values close lesser than it, minus 0.01 and positive 0.01. And all you need to do is calculate x value at what? At negative 0.01. What's the answer? Negative 0.3539. We got the same one that time as well. Now again calc at what? At 0.01. So you got the same answer. So the answer is that. So this is the way you can solve it. Now here I can easily, if you wanted, just press calc for anything. Huge numbers also you can easily put it, because you don't need to change it every now and then. So that is about it. So that's another shortcut method. Now if you're getting confused with that, you can just write the values and just delete it and again write it. It is fine. So that's the end of the lesson 3. I hope you guys have found it useful. So if you're new to the channel, I'll just remind you, please go through the first video and then watch all the lessons in continuity. And if you're not yet subscribed to my channel, please do subscribe. It would mean a lot. Have a good one. Take care and see you soon.